Hey Raiders, we're going to take a look at the third and final trig function that we're going to use in our distance learning unit here for geometry. We've already taken a look at sine and cosine. Now we're going to take a look at tangent. And remember that with these trig functions, which again are just located front and center in most calculators, all they really are shortcut ways of saying take two side lengths of a triangle and set up a ratio, divide one side length by the other. They're just shortcut ways to say that, nothing more than that. So we're going to use this one as an opportunity to introduce tangent and take a look at a slightly different scenario that wasn't covered in either of the two earlier videos. Or in this case, we might have a missing angle. We just know side lengths. Okay, so again, just as a refresher, this is based off of the idea that if you have similar figures, in this case, two right triangles, that if corresponding angles are congruent, so this angle is congruent to this angle is congruent to this angle, and the right angles are congruent, then the side lengths are going to be in proportion with each other. So that allows us to kind of figure out unknown side lengths or unknown angles based off of that fact. So for example, I haven't introduced tangent formula yet, but just to kind of see a little sneak peek of what the numbers will be, if we did tangent of 57 degrees, it equals about 1.54 approximately. So we'll come back to that. Okay, so let's set up a right triangle and say this is a 57 degree angle right here. Well, so far, when we introduced sine and cosine, sine was just a shortcut way of saying take the length of the opposite side compared to an angle and divided by the hypotenuse. Cosine was just a shortcut way of saying, all right, compared to whatever angle you're focusing on, take the length of the adjacent side and divide it by the hypotenuse. Well, tangent of any angle is just a shortcut way of saying, okay, take the length of the opposite side and divide it by the length of the adjacent side. So if we had a setup like this, if this side of the triangle here is opposite relative to the 57 degree angle that we're focusing on here. So if this is unknown, we generically call that t, and let's say this adjacent side here is 15. Notice that we're ignoring the hypotenuse in this particular case, so we don't know anything about it, but that's okay, because if we're focusing on tangent, tangent has nothing to do with the hypotenuse. So we could set up a ratio here, tangent of 57 degrees. And remember, tangent is just the shortcut way of saying take the length of the opposite side compared to the 57 degree angle and divide it by the adjacent side. So we'd have tangent of 57 degrees equals t, the opposite side, over 15, the adjacent side. So we've seen this in the previous videos. We want to get t all by itself. We want to figure out this unknown side length here. So if it's being divided by 15, multiply both sides by 15. So t equals whatever 15 times the tangent of 57 degrees is. And we know that based on similar triangles, we already took a look at it on the calculator, anytime you take the length of the opposite side to the 57 degree angle and divide it by the adjacent side, you get about 1.54. So that's going to come back around. So this is really another way of saying, okay, this unknown side length t is going to equal whatever the heck 15 times about 1.54 equals. So we'll work that out in the calculator. So, and you can type it in exactly like you see it, 15 tangent of 57 degrees, and it ends up being about 23.1 units. And what this really means is that this opposite side length, opposite relative to the 57 degree angle, this 23.1 unit long side length, approximately that long, is about 1.54 times longer than this 15, because that has to be true even if this were a smaller right triangle or this were a 57 degree angle. This side length here, this opposite side, would be about 1.54 times longer than the adjacent side. Now, a situation we haven't taken a look at yet. And we'll use tangent as a way to introduce it. So we have a right triangle here. In the previous examples we've done, we've known the angle that we're working with, and we've had an unknown side length. Well, let's say it's different than that. Let's say now we want to know what this angle is. That's an unknown, so we'll generically call it theta. So this is the departure from what we've done so far. This is an unknown angle, but in this case, relative to this angle, this is the opposite side to that angle. This is the adjacent side. Let's say we know both of these. So let's say this is 18 and this is 20. Relative to this angle, this still sets up for tangent because relative to the angle, it's the opposite side and the adjacent side. So now we can say tangent of, and instead of putting a specific angle, that's our unknown, tangent of theta equals, and remember, tangent is just a shortcut way of saying, okay, compared to whatever angle you're focusing on, take the opposite side length divided by the adjacent side length. So for us, tangent of theta would equal the opposite side divided by the adjacent side, 18 divided by 20. So we have a different situation here. Our unknown is right here, so we're gonna have to do an inverse trig function. So on your calculator, that's where the second button's gonna kick in. We'll do second tangent, and you see that it gives us tangent with a little -1. That's not a negative exponent that you have to mathematically work with. That's just the symbol to show that we're doing the inverse function. And now, just do the ratio that we have. In our case, 18 divided by 20. So it tells us then the angle is about 42 degrees. So as always, Raiders, if you have any questions, contact your teachers with the Remind app or shoot us an email. Or remember, when you're writing Odyssey where if you're working on a problem and you're stuck, you can always send a message right from that screen. Take care.